very good afternoon to all. Greetings of the World Environment Day 2024 from ISWMAW to all participants, speakers, chairs, and guests. The International Society of Waste Management, Air and Water, ISWMAW, is conducting the World Environment Day webinar. The UNCRD-DSDG and DESA and the International Society of Waste Management, Air and Water, ISWMAW India, is organizing the World Environment Day webinar with the support of SINTEF Norway and IPLA, a SDG partner. The webinar is a complement to the chosen theme of World Environment Day 2024, that is land restoration, desertification, and drought resilience, which emphasizes the importance of restoring land, combating desertification, and enhancing resilience to drought. I am Dr. Sutripta Sarkar, a faculty of biochemistry in Rashtraguru Surendranath College, Barakpur, and executive member of ISWMAW, coordinating this program with my fellow coordinators, Ms. Valerie Kosh from Kenya, and Mr. Dinesh Kumar M., a research scholar at Jadavpur University. At the onset, I would like to remind all our participants to keep your microphone in mute mode. You share your camera if you desire. The speakers are kindly requested to adhere to their timeline strictly, and coordinators and chairs will help in adhering to timeline. In the International Society of Waste Management, Air and Water, ISWMAW, was established in 2009 in India by Prof.Sadhan Kumar Ghosh for the betterment of waste management and environment protection by promoting 3R and circular economy concepts having involvement and participation of 50 countries around the world and most of the states in India, with a massive support from the governments, industries, and friends.
Sutripta, yes. Valerie has joined.
So I just read the next section on Catch Them Young, and then I hand over the microphone to Valerie.
Okay, go ahead.
As per the script. ISWMAW launched it's another flagship mission for the school and college students, Catch Them Young, Zero Waste and Circular Economy in campus, where 49 schools in West Bengal and 2 schools and 3 colleges in Meghalaya is now participating. It has taken a target of involving 100,000 students and teachers by December 2024 in waste segregation, adopting bin culture, and recycling and compost. As on date, nearly 70,000 students are practicing the same in schools and colleges. In turn, 2 million people will be made aware of waste management in these 2 states. Let us now start the business as per schedule. I now hand over the microphone to Valerie. Valerie, who is from Kenya, and she is a lead environment expert and project specialist. Valerie, you can start by inviting Professor Sadhan Ghosh for the welcome speech and the theme speech. Valerie, I hand you over the microphone.
Thank you, Dr. Sutripta. My name is Valerie Koech. I'm an environment expert from Kenya. I'm also a certified lead auditor for ISO 14001 and ISO 9001 and ISO 45001, among other international certifications, and MSc in project planning and management. So an active member of the International Society of Waste Management, Air and Water. The problem of waste management primarily lies in poor segregation of waste and governance. International Society of Waste Management involves in spreading awareness, carrying out research and implementation activities in the areas related to waste management worldwide to promote environmentally sound waste management practices, effluent treatment, air, water pollution control practices, and general environmental protection awareness in different parts of the country and abroad. Professor Ghosh has research collaboration with more than 40 countries, and thus International Society of Waste Management is involved in research projects, practical implementation projects in different parts of country and abroad. It has a collaboration with more than 50 countries. The 14th International Conference on Sustainable Waste Management, Circular Economy and IPLA Global Forum is a flagship event of International Society of Waste Management, Air and Water that will be held in Gitam University, India from the 28th November to December 2nd, 2024. Abstract and paper submissions started already, and we welcome you to submit your papers. I now hand over the microphone to Professor Ghosh to take over the program. Thank you.
Thank you. Thank you, Valerie. Good afternoon, and I welcome you all to this webinar on the World Environment Day, 5th June 2024. From the very inception of this International Society of Waste Management, Air and Water, we have been pursuing the awareness generation throughout the year, but specifically on the World Environment Day. I can remember way back to 1983, just 10 years after the inception of this World Environment Day, in the month of August, possibly, I had a 3-day workshop in a place on the bank of River Matla. It's in the Sundarbans area. The government was asking that what to do because there is a lot of erosion on the bank of Dabu, River Matla in Dabu. This is a place around, say, 70 to 80 kilometers from Kolkata, Taliganj, and it is in near Canning. So what we did is we planted 13,000 different types of trees, including mahogany, shal, shagun, and then different types of other trees, even the coconut tree, and some fruits like mango and others. So we planted it 13,000 trees in 1983. And we had the observance of silver jubilee of that plantation after 25 years. And then we observed that nearly 6,000 of plants were surviving. And you know what happens? That whenever this type of plantation is done, there are interest parties locally who takes the wood from those places and do their own business. And as a matter of fact, it is really regrettable that today, if we go there, it will be, I'll be astonished if there is only 1,000 trees are available. In 2009, we went there, and we have seen that there are a number of trees which are taller, nearly 75 feet of shal and mahogany. A single piece of this tree was costing nearly 2 lakhs of rupees that time. So the plantation program in India started long back en masse. But if we consider today, the enthusiasm of the people of plantation has come down. So the theme, if we really want to address the theme of today's World Environment Day, we have to plant a lot of trees. Each of the person should plant at least one tree in any of the places wherever it is possible. To support these activities like desertification and also the resilience, environmental resilience, what we do is we have a lot of activities in our society, in our International Society for Waste Management, Air and Water. We have number of projects where we train the people as well as the students, mainly the project which was concerned about the mission which Shutrita was mentioning, that catch them young, zero waste and circular economy in campus. We have started very recently, and our target is to involve each of the students and teachers in 100 schools, and nearly 1,100,000 students and teachers will be exposed, and they will use every day the waste management facility in the school and colleges. There are 3 speakers who will speak on this. Apart from that, we have been trying so that the waste utilization can achieve a very high level of resilience as well as high level of efficiency. Like, you know, that the waste which are dumped in the dumping site, we are encouraging so that the industries can use those waste for making cement. Like very recently, we had a pilot study in one of the biggest cement plants in India. We were observing that how much is the emission level, and even the emission level, not only NOx, SOx, but also dioxin and furan. We are also trying so that this waste can be utilized in the waste to energy plant. In India, we have only 11 waste to energy plants, and very significant waste to energy plants are in Vizag, in Guntur. So the utilization is such that, say, around 1,200 tons of waste can be utilized for producing 15 to 16 megawatt hour. And so in that, what we can do is we can encourage people to not to degrade land. Like if we dump our waste in the land, we degrade. Somewhere it is fertile land, somewhere it is unfertile land. And as a matter of fact, today the NGT has taken a very strong step that there should not be any dump site in India. As a matter of fact, the biomining process is going on, and millions of tons of waste are being excavated and making the degraded land refertile again, fertile again, useful again. And these waste are being used in different processes, like again, generation of electricity, generation of cement, and recycling process. Sometime it is going for as a organic fertilizer, and so on and so forth. So in that way, I am very happy that there are a number of speakers from different spheres of life have come forward to speak in this webinar on this World Environment Day. We will also discuss how the construction and demolition waste can be utilized as a new product and can develop business, how how the school children behave with respect to the utilization of the resources are concerned, reduce the degradation of the land is concerned, and they can make the environment resilient. With this, I once again thank all the speakers from different parts of the world and the participants who are attending this webinar. Thank you very much.
The next invited lecture is by Mr. C.R.C. Mohanty from UNCRD, Japan. I now cordially invite him to deliver the keynote speech. He is the Environment Program Coordinator of UNCRD, Japan. His significant contributions through the Regional 3R and Circular Economy Forum and the Transport Forum gave a push to the countries in Asia Pacific.
Thank you, Dr. Sarkar. And thank you, Professor Ghosh. And first of all, on behalf of UNCRD, UN Department for Economic and Social Affairs, we would like to express our deep appreciation to the International Society of Waste Management, Air and Water in India to co-organize this World Environment Day webinar with the support of SINTEF, Norway, and also IPLA, which is a SDG partnership. I think all of us know that this webinar is in support of the chosen theme of World Environment Day 2020 for this year, land restoration, desertification, and drought resilience under the slogan of our land, our future, and we are generation restoration. I think all of us know that the planet experiences continuous desertification and land degradation process, which lead to hunger, poverty, drive unemployment, forced migration, and conflict with increasing risks of extreme weather-related climate change. As per the UN sources, land degradation affects almost 2 billion hectares of land worldwide, which is home to approximately 1.5 billion people. 24 billion tons of fertile soils are lost due to soil erosion every year, and 12 million hectares of land, which is equivalent to 23 hectares per minute, are lost due to drought and desertification every year, which is estimated equivalent to the land which could produce 20 million tons of grain. And this leads to food insecurity of millions of people around the world, threatening the livelihood and well-being. Professor Ghosh was talking about the forest. If you look into the forest that we are losing out in the tropical part of the world, the loss of tropical forest accounted for 90% of the total global deforestation between 2000 to 2018 at 157 million hectares, which is roughly the size of the Western Europe. At the same time, during the same period between 2000 to 2018, the planted forest area increased by 46 million hectares. Almost 1/4 of it in this millennium replaced naturally regenerating forests, with half of it actually coming from South Asia and Southeast Asia. I think all of us know that the UN member countries are concurrently implementing a number of interlinked and mutually reinforcing international agendas and agreements, 2030 Agenda, the SDGs, the Paris Agreement, the Kunming-Montreal Global Biodiversity Framework, and the UN Decade on Ecosystem Restoration, the Stockholm Convention on Persistent Organic Pollutants, Sendai Framework for Disaster Risk Reduction, and Habitat 3 New Urban Agenda, and the Samoa Pathway in the interest of the Pacific Island countries, the small island countries, among others. And in particular, the post-2015 Development Agenda, the SDGs, adopted by the member states and the United Nations, represent a plan of action for people, the planet, and prosperity, and reflect a commitment of the countries to shift the world onto a more sustainable and resilient path. Through adoption of the Agenda 2030 Agenda, the member states call for, among others, a world in which consumption and production patterns and use of all natural resources are sustainable. Renewable and conservation of natural capital form the foundation for achieving sustainable resource efficiency and resource security. Natural capital assets are embodied in the land, forests, farms, our aquifers, grasslands, also the urban space, the aquatic ecosystem, rivers, lakes, wetlands, coastal and marine ecosystem, and the atmosphere and the dynamic cycles of the nature. The route to sustainable development is in part through minimizing the net natural capital inputs through the entire life cycle of the products and the services that drive the local, national, regional, and global economies. Let us turn to Asia Pacific region, which is the most dynamic region globally and dominates the global use of resources and accounts for 63% of the world's material use. This growth in resource has been largely driven by rapid urbanization, new infrastructure development in cities. While the economic growth has led to the higher living standards in Asia Pacific, it is also diminishing the region's resource efficiency and natural capital, shrinking forests, declining biodiversity, disappearing wetlands, and the mangroves and water resources, among others. And given the weight that Asia Pacific brings to the resource use globally, any improvement in Asia Pacific resource efficiency and circularity will have significant global impact with regard to ecosystem regeneration and restoration, as well as enhancing resilience of the countries, cities, and the communities. The circular economy principles can create the conditions for sustainable development, meeting the needs of the growing population without relying on the usage of the primary resources or the virgin raw materials. Resource security, environmental benefits, and sustainable economic growth are at the heart of the circular economy, which not only provides an important basis in SDG 12, which is sustainable products, consumption and production, but also triggers meaningful synergies in combined efforts in achieving SDGs, other SDGs, such as the SDG 6, which is clean water and sanitation, SDG 11, safe, resilient, sustainable cities and communities, SDG 13, combating climate change, SDG 14, the life below water, and SDG 15 as well, the life on land, among others. Circular economy attaches importance to the systemic approach and circular flow of resources, both renewable and non-renewable, and also provides a meaningful framework to integrate both the biological or renewable resources cycle, which is 3R, renewable flow management, regeneration, restoration of natural ecosystem and biodiversity, and the non-biological or non-renewable resources, resource cycle, that is reduce, reuse, refuse, refurbish, repair, maintenance, remanufacture, etc., while minimizing waste and increasing circularity, reducing resource extraction, and preventing the systematic leakage of waste in the ecosystems and the negative externalities. As the concept of regeneration and restoration is at the heart of the natural cycle, a circular economy, in fact, builds natural capital. Biodiversity, as well as functioning and healthy natural ecosystems are the foundation for our economies and social well-being. And in similar vein, the importance I would like to attach today is the Kunming-Montreal Global Biodiversity Framework that calls for urgent policy actions globally, regionally, and nationally to achieve sustainable development so that the drivers of undesirable change that have exacerbated biodiversity loss will be reduced or reversed to allow for the recovery of all the ecosystem, the full recovery of all the ecosystem, and to achieve the 2050 vision of the Convention on the Biological Diversity of living in harmony with the nature, so that the biodiversity is valued, conserved, restored, and wisely used, maintaining the ecosystem services, sustaining a healthy planet, and delivering benefits essential for all the people. A circular and resource efficient economy plays an important role by reducing the demand of primary raw materials or resources, which is biodiversity inclusive and has significant potential to lower pressure on the biodiversity and the natural ecosystem. Finally, to share with you the UN Environment Programme and the UN Food and Agricultural Organization of the United Nations have actually named several initiatives from Africa, Latin America, and the Mediterranean and South Asia as the UN World Restoration Flagships. And these initiatives include ecosystems from the wildfires, drought, and deforestation and pollutions. So in this regard, the World Restoration Flagships are chosen as the best examples of the ongoing large-scale and long-term ecosystem restoration by these agencies. So in this is just this example, and some of the examples of the World Restoration Flagships are, for example, the From Fire to Forest, Resilience in the Mediterranean Basin, the Living Indus River Basin Initiative in Pakistan, having a global water and climate hotspot, etc. So with this, I will conclude my remarks. Because this webinar is organized under the International Society for Waste Management, Air and Water, I tried to link actually, I tried to address the nexus the circular economy and the ecosystem restoration and regeneration. Thank you very much.
Thank you, sir. Thank you so much, Mr. Mohanty, sir, for your speech, giving a broader perspective of activities. So we begin the first technical session. And to all the presenters who are here in the first technical session, you have exactly 7 minutes for your presentation. Now I request Professor Sadhan Kumar Ghosh to kindly chair the first technical session and invite the first speaker.
Thank you.
All speakers have exactly 7 minutes.
Thank you, Sutripta. You just note the timing, okay, and keep the notification whenever the time is over. So I'll request Dr. Navakumar Mondol. Dr. Navakumar Mondol, he's a professor in Bardwan University, and he has a lot of research on waste management and related areas. So I now request Dr. Mondal to make your presentation on arts owned. Let's join hands to heal the damage.
As we all know, that this day is an immense importance for us. That is World Environment Day. Every year, we like to celebrate this day to remind or to educate the common people that our earth is not in a good position. There is really some damage. What are the damage? If you see the theme of this World Environment Day this year, particularly, you can find that is given like that: land restoration, desertification, and drought resilience. What are the meaning of that? It is just like a prescription. Once we go to the physician, if we feel any illness or something wrong with our body, physician, after checking giving some test, just like blood test, your systolic and diastolic pressure, like that. So this is like a prescription that doctors prescribe that the land, restoration required, desertification is going on, drought resilience is required. That means our Mother Earth is not in a good position. But why that is why we are in such a bad condition? Why our earth is damaging? That I like to present before you, and that's why I am giving the nomenclature that earth owns. Let's join hands to heal the damage. Actually, I like to show you one slide before you, that some of the waste I have collected photograph. It is taken from the internet, from somewhere else. All this photograph, you can see the dumping center. You can see that the municipal dumping center. You can see the next picture. This is that is vegetable waste. You can see this is electronic waste. The third one is the electronic waste, and the fourth one, it is the biomedical waste. The biomedical waste. Okay. And the fifth one, it is very recently we passed the situation that is, COVID time. We are collecting the waste in different plastic packet. Although in biomedical waste, there is segregation of the waste in the different color plastic container or in plastic packet. This concept is there. But this picture is very prominent at the time of, COVID. Now, I like to show you my next picture, that you have seen that, in a container, something is there and a blue color compound is coming. What is there? If we don't take any bother, or if we don't take any seriousness about this electronic waste or the, plastic waste, then what will happen? It is particularly damage our earth, because lots of heavy metals are there, starting from the cadmium, nickel, mercury, gold, silver. Lots of heavy metals are there. But if we cooperate, if we extend our cooperation, something that can be overcome. And that is why I like to provide you a small demonstration here. That is, suppose we have some waste ware. Normally what we are doing, we simply, this ware can, when it is out of order, we simply discard that ware. But if that ware is made up of copper, then, or aluminium, suppose this time it is copper, then it can be possible to convert it a value-added product or a valuable product. What is the value-added product? Like that, this time I like to demonstrate before you that some of the ware, that is electrical ware, that is out of order. Now it is out of order, so we should not dump it in here and there, or it is dumped into somewhere else on the earth crust, so that our mother earth will affect it. But instead of that, we can remove the plastic portion or the insulator over the ware, and to take up the copper, that portion only simple class 8 chemistry treatment. Just you have to put a copper sulfuric acid on that copper ware. It's simply converted to copper sulfate, which has a tremendous market value. Not only that, that copper sulfate is an important ingredient in the school and college, university level chemicals. So we can recover that material. We can make a value added by simply extending the cooperation, or simply a basic science, so that waste can be converted to a valuable product. Similarly, many things is going on. I am not going to details of that because I have only 4 to 5 minutes more, and that where I have to cover all the portion. That many wrong things are going on. This is an extensive stubble burning. Here and there you can go, and even in the NASA website you can go, you can see that these picture are very prominent. I have taken in particular example in 2020, where in 5th May, this red spot is indicate that the stubble burning is going on in a particular place. But the number of red dot is basically indicate that how much stubble burning is going on there. So keeping in mind this particular picture, which is provided by NASA, it is very simple. You can go to this website. I have given this address of that. So you can find that throughout this, all over the Indian map, you can see that starting from the 5th May 2020 to 15th May, to 20th May to 30th May, you can see there is a gradually decrease of the red spot. What does it indicate? Means that after harvesting of crop from the agricultural land, the farmers are not going to extensive preparation of their agricultural field. Rather, what they are doing, they simply harvest it and to burn it. That is called stubble burning, because they have no enough time to prepare their agricultural field for sowing of the next crop. So what they are doing, their common practice is that they can harvest that and simply burn it without considering that what will happen when they are burning this stubble, when they are burning this agricultural residue in this in the agricultural field. So many things are happening. I will come to the point. Just have a focus on that only. When you come to the 15th July and up to 30th July, you can see that almost negligible red spot is there, because already rainy season is coming.
Professor Mondal?
Yeah.
Sir, your time is over. Kindly summarize quickly.
Oh, sorry. So lots of wrong things we are doing, and that is our Mother Earth is affecting. And yes, lots of problem. I have lots of example where I can show you, and we have done an extensive work on that how our earth, how our globe, how our environment are affecting from that activities. And that normal activities, but common people have no idea that how they can make their kitchen room at least their kitchen room. So that is even nowadays, if you enter in your ATM center, after transaction you will get a small paper, that is thermal paper. It's a very dangerous. What is that? Why I am considering this part? But because after transaction, when you check your transaction, this paper is simply discarded into the roadside or in your home, garbage here and there. But you don't know how much toxic substance in this thermal paper, bisphenol A. This is a endocrine disrupting chemicals. So lots of things, but everything we can manage if we think properly. If we can manage every toxic material, every danger substances, we can manage. I have a lot of I thought that I have to say many things about that, but I think there is no more time to share all these things. So once again, I like to share my some recent problem. Plastic. This is another problem. But recently we make some find out that that this plastic can be a beautiful antidote of mosquito, and that was published in a high impact journal, the Journal of Cleaner Production, more than 11 impact factor right now, more than 11 impact factor. So that is what I'm trying to say. Recently, 2024, again, one work we have done, that the plastic can be a suitable agent to kill the mosquito without, discarding it here and there, without damaging our Mother Earth. We can manage it. In this way, we can save our Earth. So thank you very much. Thank you, sir, giving me this opportunity to share my views regarding this issue. Thank you. Thank you all.
Thank you. Thank you, Professor Mondal. You have brought a very new type of information, and it is really very much needed for us to think of that how the art's wound can be reduced, and the disposal of chemicals and other materials can be reused instead of disposing and depleting. So, however, please be with us that we will have the question answer session at the end of these 5 presentations.
Okay.
So now, thank you very much. Now I will request Dr. R.M. Lingdo. He is the principal in Synod College, Shillong. He is the first person to lead our mission, Catch Them Young, Zero Waste and Circular Economy Campus in Meghalaya, and inaugurated the facility on 1st December 2021, as I can remember. So now over to Dr. Lingdo.
A very good afternoon, sir. Good afternoon, ladies and gentlemen. It is a great honor to get this opportunity today to discuss an issue of profound importance, focusing on land restoration, desertification, and drought resilience. I'm Dr. R.M. Ningdo from Sina College, Shillong. Desertification, it is one of the most pressing environmental issue of our times, and it's threatened the livelihood of over 1 billion people in more than 100 countries. And the loss due to desertification, there is a loss of biodiversity, diminished agricultural productivity, and increased poverty and food insecurity. And the consequence of desertification, the loss of biodiversity, diminished agricultural productivity, and increased poverty and food insecurity. And in the land degradation, and we have to focus on this land restoration because the healthy soil and the restored land act as a significant carbon sink. And the key area to focus is to address these challenges. We must focus on restoration, resilience, and community empowerment. And in land restoration, like reforestation and afforestation, sustainable agriculture, and the water management, it is one of the most important that we have to act now. And we have to a building of a drought resilience by innovative water management technique, rainwater harvesting, improve irrigation practices, restoration of wetland, and integrating the traditional knowledge with the modern scientific knowledge. And we have to have the community empowerment. The success of the land restoration and the drought resilience effort, it is by engaging the indigenous people, the students, the farmers, and the local readers, and also to provide them education, resources, and financial support so that we can have a sustainable outcome through the community involvement. And in Synod College Shillong, as Sir has mentioned, like we have joined the International Society of Waste Management, Air and Water on 1st December 2021, and we have started the waste segregation at point source from the year 2022. And in Synod College, the solid waste within the college campus has been segregated at the point source, and we have the biodegradable, recycle and plastic, glass, as well as recyclable papers. These are all the ways that we have to teach. We taught our students how to dump in the proper place at the point source so that it'll be easy for the municipal workers to segregate them, and also the non-recyclable where we directly give to the municipal truck for landfill. And at each point where the different bins are located in the college, we have this signage like in Synod College Shillong, know your waste, and we educate the young minds so that we have to catch them young so that they will know how to segregate the waste at point source. And this is the inauguration of the waste management in the college campus, as mentioned by Sir, on the 1st December 2021. And these are the waste bin that we kept in the laboratories and in hostel as well as in the PG campus. And these are the volunteers for the waste segregation, monitoring, and the data collection by the volunteers which have actively participated in the college. And we also have extended the waste management project to different schools and colleges. At present, we have, along with Synod College Shillong, we have the Synod College Nong Soin, as well as the Mairang Presbyterian College, and we have different schools like the Nongra as well as the Sharon Memorial Schools. And these are the photographs at the time when we inaugurate the waste management project in different schools and colleges. And these are the place where the where we kept the waste segregation and also the compost pit. And these are the tree plantation which takes place in one village in the coal belt area in Giant Hills. And we, the Synod College, they have started right from the year 2014, and sometimes they lost their way. But in Synod College, from the year 2021, we have joined hand with them. We have an MOU with them, and we educate them like about the even not only the tree plantation and also about the waste management. This is the volunteers from the village. And after 10 years, you'll see the second photograph. And also we teach them about the rainwater harvesting as well as the water treatment plan. And these are the volunteers from the village during the tree plantation, and also not only during the World Environment Day on the 5th June, we also have this participation, like a community participation, even on the 22nd March, where we always celebrate the World Water Day. And these are the volunteers from the village where they grow the carpet grass. And here we have seen the aerial view of the village. This village is located in the East Giant Hill district in the coal belt area, but in the 10-year span of the active participation of the community or the villages, that means they have changed the coal belt area into an oasis of greens. And these are the view of the village during the festive season. Like the villagers work hard throughout the year, and in the festive season starting from October to January, these are the decoration that they have done in the village to attract more tourists. And this village also has been awarded as the cleanest village in the last International Society on Waste Management, Air and Water, which recently held in KJ Somaya Institute of Management, Mumbai. And our commitment in the future is like to address desertification and drought resilience is the commitment for the future generation. By focusing on land restoration, we pave the way for sustainable and prosperous future. And the call for action is, let us take action with urgency and determination. Let us work together to restore our lands, build resilience, and then ensure a thriving planet for all. The time to act is now, and the power to make a difference lies in our hand. And we have to join the race to make the world a better place. Thank you.
Thank you.
Thank you so much, Dr. Lindo.
Thank you, ma'am.
Yeah, thank you, Dr. Lindo. It's really amazing and very encouraging, the activities which you have been carrying out in your institute. And also you are propagating this to different So we will now listen to Dr. Choitali Mukherjee. She is an assistant teacher at Santoshpur Rishi Aurobindo Balika Vidyapit, Kolkata. And her topic is restoration of urban ecosystem in the mission, Catch Them Young, Zero Waste and Circular Economy in Campus. So, Choitali Mukherjee, you have 7 minutes to make a presentation. Please.
Thank you, Professor. Thank you so much.
Thank you.
I'm so sorry, I got involved into something else and then couldn't come out of it immediately. But I request Dr. Mukherjee to proceed with the presentation. Thank you so much.
Thank you.
Thank you, sir. A very good afternoon to all the dignitaries, respected guests, and Professor Ghosh. I am honored to speak in this distinguished platform. So for this, thank you, Professor Ghosh, for giving me a chance. Today, my topic is restoration of urban ecosystem in the mission Catch Them Young. This is my school, Santoshpur Rishi Aurobindo Balika Vidyapith. This is my school. It is located in the heart of the city, and the students came here are almost 5-generation learners, and we are always trying to get them a holistic environment. Now, there are several ways for restoration of ecosystem in urban area, but we are focusing the waste through this mission, Catch Them Young. Why we're telling them? Well, this is the theme of the year. I'm not discussing this. Since few years in our school, we are following some sustainable system in our school. That means the presence of solar panel, source of clean energy, rainwater harvesting system for water conservation, and a beautiful rooftop garden, source of organic vegetables. This is the our garden, rooftop garden. You can see that seasonal vegetables and fruits are produced here. These are the vegetables, and they used for midday meal menu to the students, and thus the students got the nutritious food from here. This is the green waste. They are used for preparing manure. Now, why waste management? Because in urban area, we know that there is a huge amount of waste, solid waste produced, and the number of recycling plants are not enough to handle this waste properly. So the landfills are overflowing. When we are thinking about this, how to manage this type of waste, because we know that anything we do, it can produce a waste. So what can you do this kind of waste? Even an educational institution, which has not so much money to handle this type of management, then Professor Ghosh came with this noble mission, Catch Them Young, Zero Waste and Circular Economy in Campus. The significance of this mission lies in this name, Catch Them Young, not the common people or not the adult, because it is easier for the young generation to adapt themselves some sustainable habits into their daily routine from the very childhood than any other. If they were aware, they will aware their parents, and next in turn they will aware their society. Then we can move for a sustainable future. So in this mission, within a very short period of time, 51 schools and almost 72,000 students were involved in this mission in West Bengal. And the first step of this mission is introduction of green culture, because in waste management is very crucial for segregation of waste at the source. And for this, we have got 3 sets of colored bins for bin culture facility system. Next step is to measure the amount of the waste produced once in a week, so that we can think about the ways to reduce the waste. Next, to explore all the waste produced. It cannot be managed by us. So to explore the local vendors who will purchase the dry waste from the schools. If we are selling the dry waste to the vendors, then if we get some money, then waste has a value. In the urban area where schools have the space scarcity is there, and the schools where space is available, they can make compost on the ground for their biodegradable waste or green waste. And for us, we are thinking this type of waste on our rooftop. Finally, on 12th April, we have celebrated the International Day of Zero Waste, conducted by ISWMAW and our school. Here you can see that sir is demonstrating the use of the colored bins, into which waste can be distributed to the student. These are the set of colored bins. These are installed in each floor with the guideline, so that the student can use it properly. A rally for waste management with placard and slogan was organized on that day. Not only our schools, our 8 neighboring schools with their students and their teachers, they also join in this program. Yes, ma'am.
You have 1 minute left. Thank you.
Okay, ma'am. This is the rally for social awareness, and this is the oath-taking ceremony. And then Professor Ghosh told about the significance of different color bins, segregation of waste, and the value of the waste. And there is an interesting thing. An exhibition was held made of recyclable materials by the students, not only our students, but the students from different schools. They also came with their things. And at that moment, certainly an idea came to our mind that an auction may be good with these things, and the students are agreed to purchase, to sell their products to the teachers, and thus ask the price, and the highest price were given to them. And this is our principal of our school. These are the teachers and sirs with the hands, the purchase things. So the implementation of circular economy has been introduced in our school, and the neighboring schools who are our collaborating school in this mission, they have also distributed to these bins so that they can introduce this bin culture facility in their school. They are also becoming a part of this program. And last, our future planning is to install a composter with the guideline from SIR. This is the basic structure of composter, and this is the space given for the composter. And if we can successfully make this compost, it will be helpful for our garden. And we can extra compost we can sell outside. Then we can say that waste is wealth. Thank you so much for patience hearing. That's all. Thank you and regards.
Thank you, Dr. Mukherjee. So nice and excellent presentation on how this initiative can be taken forward among the children. Also, a good explanation, good insight of for many stakeholders to take it forward. So I think it will be very useful if this particular initiative is taken up at various different institutions as well. Thank you very much for that. Professor Ghosh, I may have to blank out for 2 minutes, so yeah. I'll get back again. Please.
All right.
Okay.
Let me then call. Chaitali Mukherjee, you had a very nice presentation, and I'm very glad to hear from you and your presentation materials. So now we will invite Dr. Soma Shur. Soma Shur is the Honorary Director of Frau Lafont Center for Excellence in Research and Innovation, and she's a professor in the Management Department of St. Xavier's University, Kolkata, India. Professor Shur will speak on climate change, disaster, and the Sundarbans.
Yes, good afternoon, Professor Ghosh. Can I share?
Yes,
from my
please
side?
share your PPT, and you have 7 minutes time.
Okay.
Sweet.
Yes, surely I'll do that. I would first like to express my gratitude to the International Society for Waste Management, Air and Water for inviting me as a resource person in the World Environment Day 2024 webinar. And I would particularly like to thank Professor Ghosh for giving me this opportunity to participate in this such a international forum. Yes, of course, we all know that today is the World Environment Day, and we are trying to, of course, enlighten others also, and rather, I would say, inform others about all the activities and things that are going on, creating the awareness about environment issues, which at present has become so very pressing and grave concerns, posing challenges to not only the humans, but also the flora, fauna of the total our Earth, planet Earth. Our problem has not started today. It is, of course, started, I would say, much longer before. And we have been, in fact, celebrating our World Environment Day for more than 5 decades. The few of the pressing concerns right now ranges from climate changes to global warming to deforestation. And I have chosen my topic for presentation today, which is climate change, disaster, and the Sundarbans. Yes, of course, I would discuss a bit details about how climate change is affecting or posing a challenge, but I would like to first mention that why I included Sundarbans. Sundarbans, of course, is a place which is very near, for that matter, from the city where I live, Kolkata, and many of us also live, which is just about more than 100 kilometers from here. But the immense challenges and the problems they're facing due to the climate change and the disasters that are taking place there and affecting the livelihood of people who stay there, we may not be really aware to that extent, because that is something which we are not seeing in our daily life. So I would move forward with just a few words on climate change, which refers to, I would say, the long-term shifts in temperature and weather patterns. And these shifts in temperature and weather patterns may be because of natural reasons, but most of the times what we find today is that it is due to the human activities that has been taking place for the last 2 centuries. In fact, with humans going forward with the development, had been doing a lot of things which at that point of time after Industrial Revolution they felt was meant as development, but which actually was not a full or integrated development for the whole world. And those became the main drivers of the climate change, which the effect of which we are facing today, which we know is primarily due to burning of the fossil fuels, which produces this heat trapping gases. And because of this greenhouse gas emissions, which has actually trapped the sun's heat, and this led to the global warming. Global warming and climate change are now become almost a layman's term, and we do understand. But very important is that the world is now, or rather, warming at a pace which is at this point fastest in the recorded history. And we all have seen in the just last month, our own country, there were so many cities and places where mercury levels went above 50 degrees and has taken a toll of human life of more than hundreds. So it is a very grave problem in the situation that we are facing. The basic causes, as I already mentioned, because of human activities they have become the main drivers. Though at one point of time, human beings and nature was in harmony together, but slowly we have reached this phase where, because of development, we have been using fossil fuels for generating power, for manufacturing of products, for even most of the transportation that we uses those fuels, for urbanization. And not only that, even we have the deforestation, that is cutting down of forests for maybe farmland, pastures, or for other uses. But what the impact it has created is very high, and that's what we see, that it has posed many risks to human beings, and not only human beings, in fact, all forms of life on Earth. And
Dr. Soma?
we have, yes. Yes, hello.
You have a minute left.
1 minute left.
Summarize. Yes, summarize. Thank you.
Okay, so I would like to say disasters are very serious disruptions to the functioning of the community that exceeds the capacity to cope with its resources. Now, this disaster which the Sundarbans have faced. Now, what are Sundarbans? Sundarbans is a vast mangrove forest located in the Delta region where it has a unique ecosystem with many endangered species, starting from Royal Bengal tigers to pythons to crocodiles and dolphins. And not only that, the people living there with various communities. Now, this is a part of Delta region, both in India and Bangladesh. And it is about more than 10,000 square kilometers, where it's very vulnerable area for the disasters to take place. Now, the main things that have the climate change is affecting is, of course, rising sea levels. And because of this rising sea levels, we find that a whole lot of islands have already gone under the sea, and many more are going. The disappearance of these islands in this delta region is leading to what? Is leading to environmental refugees. People have to shift their places where they're living. They're moving inwards, and in fact, we see persistent flooding causing this. So they have become refugees in their own lands and moving towards the inner path, unable to maintain a livelihood, proper livelihood. Another major problem is the salinity, the saline water, which is actually threatening the freshwater aquatic life and also the farmlands. So we find that Sundarbans is, of course, a very disaster-prone area where cyclones, tidal waves, sea level rise, earthquakes, rain, lightning, everything is very common, and they have to go with that. It has been declared as the most cyclone-prone area. We have also predictions that a lot of cyclones, the directions are shifting towards this, and the frequency of the cyclones have also increased tremendously of the last 2 decades. And this is where we find is the future is really alarming, where all people at the Sundarbans, not only
Thank you so much for that insightful presentation I've learned something new about Sundarbans. We don't have that here in Kenya. So I'll hand over back to the chair to invite our next presenter.
Thank you very much. Thank you, Dr. Soma Shur, for your overview on the climate change, disasters, and in Sundarban, what is happening. So now I would invite Dr. K. Shivakumar. Shivakumar, you are here?
Yes, sir, very much.
Okay.
Good evening.
Yeah, good evening. And he is the head of Concrete Technology, BNFIC, L&T Construction, Chennai, India. So he has done a lot of work on construction and demolition waste management. As I was referring, said this is one of the areas where the restoration of the landfill sites are vulnerable, and this can be one of the solutions which they are working for. And I now request Dr. Shivakumar to make your presentation on construction and demolition waste management and environmental restoration. Over to you, and you have 7 minutes time. Please.
Good evening to all of you. Thanks to Professor Ghosh for giving me an opportunity to present in this forum. So I am very much heading the concrete technology function. I am working for a large contractor. So my talk will be intertwined around the use of concrete. And I hope all of you can hear me well, and also my screen is visible.
Yeah.
So this UN SDGs, the 17 SDGs, the keynote speaker, Mr. Mohanty, has already explained. So I'm not going into the details. moving on, India and SDG is a connection. So if I look at SDG number 11, so it says it makes cities and human settlements inclusive, safe, resilient, and sustainable. So it is not a too difficult thing to expect that all the people should have a concrete roof over their head. So someone should have a proper housing so that where they can live and then properly enjoy their family life and also go to the work. So this is something, a basic requirement which any aspiring and developing economy wants. And the government of India has also got an ambitious housing program, urban transformation through housing for all. And it is work in progress because our population is also growing, and also our demand is also catching up fast. So if you look at the different construction materials that are available, so bricks, fly ash bricks, stone, bamboo, tiles, concrete, among all these materials, as far as India is concerned, concrete is a popular material of choice because it is flexible. Anyone can make concrete and also it is available throughout the country. So concrete is a favored material of choice. Why concrete is a favored material choice? Because it is quite simple. You buy Portland cement from a shop and then you mix with aggregates like stone, sand, and if you add some water, it has a cementing property. And after a few hours, it becomes like a rock. So anyone can make it. And modern technology, there is also a technology whereby you can see a lot of transit mixers on the roads. So also it's all mechanized production these days. So mechanized market occupies about 71% of the total consumption of the concrete in India. So if you look at this thing, the concrete production volume is something around close to 6 billion cubic meter per year. So our cement production is around 350 million, out of which half of it goes into making concrete as a product. And to make concrete, the 3/4 of concrete composition comprises of aggregates, that is stone and sand. So without which you can't make concrete. So it is quite an important component of concrete. So then conventionally what happens is the natural aggregates are mined from a quarry. It is well defined and it also goes through a crushing process like jaw crusher, cone, and impact. And finally you get aggregates of various sizes and shapes. So this process is well defined. But if you look at the demand for sand across India, it is a huge demand because the government has to step in to regulate the sale of sand also. It is closely connected to the economy and also the livelihood of so many people. And if you look at the Tamil Nadu government, they also developed some software apps so that you can order sand using an app. And the recently revamped site also of the TN government, it also has a provision for buying imported sand also. So sand as far as from Malaysia also comes to the ports. So some of the SDGs, so it's not only the out of the 17 SDGs, so we are also, you can't stop the natural ferrying of material because you don't want to keep people in poverty. Though SDG 1 says that no poverty, and also people have an entitlement to proper work and economic growth. So when there is a heavy rain, floods, so sand accumulates across the riverbed, and it is natural that people cart it off away for some construction work. And India is also on way to a circular economy. By 2030, India wants to be seen as a circular economy. So we are moving away from linear resource consumption to more of recycling of materials. So if I look at construction demolition waste, it is generated due to various reasons, failure of buildings or natural events, or if an infrastructure is very old, you want to build something new for the developing demands. Okay, then the legacy infrastructure has to be demolished. And even when you demolish nuclear sites, so this concrete can also be reused. This is being done in the UK. And sometimes, unfortunately, what happens is in India, most of the time, C&D waste is dumped in landfill sites. So without realizing the potential value. So this is also a huge problem India is facing. And if there is a hurricane or a cyclone, again, the seaside properties get damaged and again, C&D waste is getting generated. So if you crush this material and make it as aggregate, it's called as recycled aggregate. So which means it can contain asbestos and all sorts of materials. But if you are processing only concrete, then it is called as a recycled concrete aggregate. So here I am showing a photo from a metro site near Thane, where the aggregates have been crushed. So it goes through several processes and you can get coarse and fine aggregate. So fine aggregate is nothing but sand, less than 4.75 mm particle size. So if you look at the C&D waste generated across India, the rough estimate is around 760 million tons. So across various municipalities in India, C&D waste is getting generated. But how much of it is actually getting processed and reused, that is a big question mark. But nevertheless, there are new plants, sophisticated plants coming up. For example, in Delhi, there is a modern C&D waste recycling plant. And as far as in the year 2022 is concerned, there were about 28 plants across India. And the current status is slightly, there is some improvement. There are 4 new plants have come up in Hyderabad, 2 in Chennai. If I look at Chennai, for example, the C&D waste generated is around 800 tons per day. But somehow there are only 2 plants and they combined together, they have a processing capacity of only 500 tons per day. So much needs to be done and more C&D waste processing plants needs to be established to properly place all the waste into construction.
Dr.
So yeah.
Dr. Sivakumar, you have less than a minute left.
Yeah, I will
Kindly
go on.
summarize. Thank you.
So the Indian code has given some limits whereby C&D waste is processed C&D waste can be reused in concrete. And we also did a project for our own precast factory. We did a grade slab with C&D waste. So we replaced the natural sand with 50% of recycled material. And even after 3 years in operation, so we got all the debris from this metro site and it was processed in a proper recycling plant. And even after 3 years, this slab is in very good condition under all sorts of moving loads. And also we have published a paper in the Indian Concrete Journal documenting this thing. And since this was supported by SINTEF, we also got the visitors from Royal Norwegian Embassy, and they also appreciated us for this work. And also we got an appreciation certificate from SINTEF. So the problem is for a large contractor like this, consistent quality of large quantity of debris and then availability of aggregates as a final product is always a challenge. So there can be instances where you can establish on-site crusher facility and crush good quality debris. For example, this is a photo from a Hyderabad site, but unfortunately we are not able to establish an on-site crusher and we have to cart it away. The other thing is you can, whenever you demolish a building, you can recycle the aggregates then and there at the site and use it for new construction. So this has to be the way forward. And this is a skyline of Dubai. So wherever you see high-rise buildings, you see them as reservoirs of aggregates. If you are going to demolish it at some point of time, all the demolition has to be processed and used as aggregates for new construction. This is a way forward.
Thank you so much. Your time is up,
Yeah, so to close, I want to remind about the SDGs and thank you for this opportunity. Thank you very much.
Valerie, let him close the session. Okay. He was still speaking. However, Sivakumara, it was a very nice presentation and informative. So as I was referring to incorporating more data, you have already incorporated, and that will be really interesting for all of us. Thank you very much. So I can see a point from Mr. A.K. Sengupta. He is from FOSMI, Federation of Small and Medium-Sized Industries. So he wrote that Professor Mandal from Bardhaman University has shared valuable tips on recycling copper and plastic waste. Initiatives like this should not be confined to academia. It's crucial to disseminate this information to manufacturers, especially MSMEs, given the strict enforcement of EPR regulation. Industry-academia interaction is essential for this purpose. Yeah, you are right, and it is necessary to propagate this to the institute and as well as the industries. I must conclude this session that there was 5 presentations which were very much different from one to other, excepting Dr. Choitali Mukherjee and Dr. R.M. Lingdo, because their presentation is mainly how they encouraged and also involved the school and college children in restoration of the landfill site indirectly by incorporating the bin culture in the school, utilizing the waste for recycling, and also plantation. The presentation made by Dr. Mondal, it is really interesting, and he talked about the arts wound. There are many wounds which we are creating, the man-made wounds from different types of activities, mainly the use of chemicals, their disposal, use of plastics, and also he mentioned one innovative idea about the plastics to convert into antidotes. And then Dr. Soma Shur, she has presented and given us some idea about what is happening in Sundarban and what is the situation in Sundarban. She is also concerned about, she shows the concern about the disappearance of number of islands in Sundarban, which is really a very important aspect which has to be looked into by the government. And of course, very recently, we also experienced a cyclone in Kolkata. And Sundarban, it is a cyclone prone, and there are a lot of problems cropped up from different types of cyclones. And lastly, Dr. Shibo Kumar, he has also given us a fair idea about how the construction and demolition waste, whose destination a few years back, even today, is again the landfill site for destroying the land, can be converted into a valuable product and also a valuable business. So in that way, these 5 presentations were very important for this audience, and a lot of learning from this, I must say. And thank you very much for each of the speakers for your presentation and spending valuable time to share your thoughts and ideas. And I am now closing this technical session 1. And now I'll hand over to the coordinator, Dr. Valerie Koech, so to invite the chair of the second technical session and request to start the session. And I'm quite sure that the speakers of second session are already here, like Dr. Kare Hegle, Kare H. Karstensen, Miss Monica, then Srinivasa is already there, Biddut is already there, and however others will come. So over to Valerie.
Thank you so much, Professor Ghosh, for the summary of the first technical session. Now we are about to start our second technical session, and it is my pleasure to introduce to us our chair for the next session, Mr. Palash. Mr. Palash is from Norway and has worked with the SINTEF since 2014 on international waste management projects funded by Norwegian government. SINTEF is one of Europe's largest independent research organizations. Previously, Palash spent over 8 years with GeoCycle, Holcim Waste Management Division in supply chain, business development, project and operations. He has authored numerous articles, provided training, and presented at international conferences. He believes in building strong relationships and in delivering innovative, sustainable waste management solutions. Welcome, Mr. Palash Kumar. Thank you.
Can everyone hear me loud and clear?
Yes.
Yes, we can hear you.
Yeah. Thank you for the opportunity to chair this session. Today, we are happy to have distinguished speakers from the industry, academia, and research institute who will discuss on topics ranging from resource efficiency, circular economy, reducing GHG emissions in built environment, and various outreach activities. These topics, of course, directly or indirectly relate to this year's World Environment Day focus, which is on land restoration, desertification, and drought resilience. So we will begin with a keynote presentation by Dr. Kåre Helge Carstensen, who works as a chief scientist at SINTEF, and he will speak for 10 minutes. Following that, each speaker will have 7 minutes to present. Okay, while I know all of you have much to share, but I would kindly request you to focus on the key messages you when 1 minute is left. So I give it to Dr. Carstensen to give his keynote presentation, please. Over to you, Dr. Carstensen.
Thank you. Thank you. Thank you. Okay, good afternoon, everyone. I will make a short presentation about where we are actually investigating and exploring if cement kilns can be used for disposal of non-recyclable plastic waste. You may know that plastic has been produced now for more than 70 years, started in 1950s, and up to now, more than 6 billion has already become a waste out of the 9 billion. Only 9% has been recycled, 12% has been incinerated, and it leaving us with almost 80% of the 6 billion ton being in dump sites, in environment, and in landfills around the world. And this constitutes a really ticking time bomb, basically because we have a huge amount, and in these dump sites, as you can see on this photo, plastics will slowly break down into microplastic and spread into all environmental compartments and creating a continuous flow forever. This will enter into groundwater, rivers, it will be everywhere, and it will cause huge damage to fish, to all life in sea, and even to our own human health. Microplastic can today be identified in almost every part of our bodies, including lungs and the stomach. And we have seen that it can cause blockage of blood vessels and is found to double the risk of stroke and heart attack. Microplastic has also recently been linked to reduced fertility, and it has been found in men in huge concentrations. Toxic chemicals in the plastic will also probably be released into organs if it's embedded into the organs and cause additional possible health impact. It means that large-scale treatment solutions is needed for non-recyclable plastic waste, and that is urgently needed. You know, there is a global agreement on plastic waste management going on now. It's under negotiation and it's supposed to be agreed by the end of this year. And they focus on reducing plastic production, consumption, maybe make other types of plastic. But there is nothing about how to deal with the plastic, which is already there, more than 5 billion tons. What we do with that? If you look at the picture on the right side, you will see that some of these plastic items will be in the ocean and in the environment for hundreds, maybe even thousands of years before they break down. That's why we, a few years back, initiated a project called Ocean Plastic Turn into an Opportunity in Circular Economy, or short OP2C, where we aim to investigate the role of the cement industry and to evaluate its potential to increase treatment capacity for non-recyclable plastic waste in 5 countries at the beginning: China, India, Myanmar, Thailand, and Vietnam. Today we are more countries, but anyhow, and of course the primary objective of this project is to help to reduce the release of microplastics to the sea. This is funded by the Norwegian government and is part of its effort to reduce microplastic in the oceans around the world. And why is this project initiated in Norway? Well, we are probably among the countries in the world which has most experience with use of cement kilns. Cement kilns are high temperature rotary kilns which can actually dispose of, for example, organic hazardous waste like oils, pesticides, thinners, etc., etc. And we have been using these kilns in Norway to dispose all the organic hazardous waste generated for more than 30 years. And of course, also plastic waste. And today, the cement industry in Norway replaced more than 75% of its coal with various waste streams. So it's a win-win opportunity. We didn't need to invest in, costly, dedicated hazardous waste incinerator. Instead, we invited the cement industry to come forward and present a solution. And our company, our research company, SINTEF, has been part of that journey all the time. The 5 countries that we are working in, the Optosea project is hugely important. They have 3 billion people, half of them live in coastal area, and they have a very high plastic consumption and produce huge amount of plastic waste. Can you imagine? More than 200,000 tons of plastic waste every day is produced in these countries. And they have one thing in common, and that is insufficient waste treatment capacity. But they have something else. They have the biggest, high energy consumption in the world in cement production, in steel production, and electric power, using tens of thousands of plants which consume vast amount of coal and significantly contributes to the global emission. If some of that coal can be replaced with non-recycled plastic waste, which have absolutely no other use, then it's a win-win opportunity. And this is what we explore in our project. Burning waste or co-processing waste in cement kilns have many benefits. It's already there. You don't need to build anything. It operates 24/7. It has a very large waste treatment capacity compared to, for example, incinerators. It's a complete and final disposal solution. There are no future liabilities, for example, compared to landfills. There are no residues created. Everything is recycled into the process. It's high temperature, destroy all hazardous chemicals, also in the plastic waste, of course. It has a very efficient energy recovery, much more efficient than waste incinerators. And emissions will normally be unaffected if done in a responsible manner. It reduces the coal and raw material consumption, of course, and CO2 emissions compared to building new incinerator or putting things to landfill. And very important, it's usually very cost efficient because you don't need big investments to use cement kilns. Now I will show you just very few examples of the waste streams that we are now been testing for a few years in Asia. And these are large volume non-recyclable waste streams, like, for example, plastic from dump sites and landfills, plastic from larger rivers, like the Yangtze River, for example, plastic from industry, like cement recycling, paper recycling, and plastic from recycling activities in big cities. And I will just show you a very few pictures. This is from North Vietnam. They have several recycling villages. And here you can see what ends up becoming a waste after recycling activity, huge amount of pollution. Even open burning, as you can see here, and they have a big problem, and it needs to be dealt with. We have conducted, pilot tests in various nearby cement kilns, like this one in QNC in Vietnam. Last week, we did a pilot in ISWMAW Naidal cement plant in Andhra Pradesh, which is the world's most energy efficient cement plant. And we were actually testing multi-layer plastic waste, feeding almost 10 tons per hour, as you can see here, into the cement kiln, replacing coal. And we also had biomine plastic waste from dump sites in Chennai and Hyderabad, feeding at a slightly higher rate. And all this replaces coal, and we save coal. And this is my summary slide. We have up to now conducted 16 pilot demonstrations in these 4 countries with various types of high volume non-recycled plastic waste, and tested this and proven that the technology is feasible and environmentally acceptable for co-processing in local cement kilns. These tests has also shown that feeding plastic waste does not affect emissions to air pollutants, including dioxins. We have never seen any measurement which has exceeded strict emission limit values. Annually, these cement plants will prevent at least 650,000 tons of plastic waste from entering the sea, while saving over 350,000 tons of coal each year. And of course, significant amounts of CO2 will be saved, both directly and indirectly. We have conducted a huge amount of outreach activity, and we have reckoned that more than 6,000 people have participated in more than 50 workshops that we have organized. And we have created a lot of papers, books, and book chapters, etc., which you can find on our webpage. Thank you.
I'm requesting Miss Monica from JSW to present on their journey of GHG mitigation in their cement plant and other industries. Thank you. Over to you, Miss Monica.
Yes. So wish you all a very happy World Environment Day. I'm thankful to Professor Ghosh for inviting me to be a part of it. And the topic I have chosen is the built environment because I feel that there is little less awareness about the topic while we all are representing some sectors, industrial sectors, and we have some decarbonization approaches. But apart from that, I would also like to talk about something new. I hope some of you would be able to get some new insights around it. So my question was that what is common among all these buildings, whatever you see? So one material which is all common and which has been used for ages now is the limestone. All these structures you see, though they have been built in different era, but every structure have used limestone as a primary construction material. There might be some difference in the PISA, which has used marble as well, but limestone also was the one of the material which was used. Next. So limestone is exceptionally weather resistant material and it's very, very durable. That's why it has been used, and that is very, very evident from the structures which has been built for many years and still you see today. However, in around 19th century, 1824, next slide. So in 1824, the cement was invented by Joseph Aspirin, who did some kind of experiment at his kitchen itself. And that's how he invented something new, some new construction material, which is being used since then. And if you go to the next slide, and for last now more than 100 years, it has been used and the construction grew and grew. So next slide, please. Okay. So here, so this slide, so since then building and construction grows continuously, and now we, just next slide. So I'm sorry that I'm not able to click the slide myself. So next slide. Next. So now we see that all around us, it's only the building material which is coming on. Okay, there is some change in the slide, I guess. I was talking to the slide number 6 actually. So there are predictions that whatever is being built in the future. So and by 2030, the world building stock is expected to double by 2060. And most of it is yet not built. So you can imagine that amount of cement which would be used for this construction material. And this is what we call as built environment. Now, when I relate it to the carbon emission journey or carbon emission quantum, so the built environment is responsible for 40% of global carbon emission, which approximately is 15 gigatons of carbon each year. So that's why you would have all heard that we will build net zero building. So whatever targets everybody is setting, be it government, be it industry. So until or unless you take care of the built environment and the carbon emission coming out of that, probably we would not be able to reach the net zero future in any of the sector or for this planet per se. So under built environment, next slide please. So under built environment, there are two kind of carbon emissions which are responsible. Okay, so I'm so sorry. So these slides are coming up and down. So the built environment, while I said that 40% of the global emission is coming from the built environment, at the same time, 35% of energy is also is responsible for which is used in building these structures. And when I divide this emissions, or the carbon emissions which is coming from the built environment, those are divided into two categories. Next slide, please. So one is operational carbon and one is embodied carbon. So operational carbon, most of the people relate to the operational carbon. That means whenever they say that they have the net zero building, they mostly relate to the electricity what they would be using. So they will say that we will be using solar panel above our roof. So all the electricity, whatever we would be using, those would be coming from the renewable sources. But if you actually get into the nitty-gritties of it, so what we say, that building cannot be called net zero until or unless you address the embodied carbon amount of it, which is responsible, which is actually contributes almost 40 to 50%. So 40 to 50% of the total carbon is actually the embodied carbon. And embodied carbon, if I define it, so this is the emissions which are coming from the manufacturing, transportation, and installation of building materials. So that means when you are making any building or any structure, so you would be using, say, steel, say, cement, and until or unless you reduce that carbon which is emitted by the manufacturing of cement and steel, probably the building would not be called as net zero. So next slide, please.
We need to summarize. Yes.
Yes. So this is the emission profile of the building. So where you see that 66%, 2/3 of the emission are coming from the cement only. So that's why I represent a JSW. I represent JSW Cement, which is into the cement building material thing. And that's why we are taking efforts to reduce the carbon emission into our manufacturing process. So next slide, please. Next. So JSW Cement is comparatively a newer. Okay, so next slide. So cement. So this slide only talks about the cement industry. Also contributes almost 7% of the total GHG emission. Next slide. So we are on
Ms. Monica, you have 1 minute.
Yes, I'm finishing it. So let's go to.
Thank you.
So okay, just hold on. So I'm on slide 12. So in cement manufacturing, most of the emissions are coming from the clinker manufacturing, and at JSW Cement, we have reduced our emissions in last decade almost to 1/3. So we go to slide 14, I guess. So that probably would be the last. So this slide presents our journey, our sustainable growth journey. So where we say that over the last decade, our production has gone 4 times. However, at the same time, we have reduced our emissions to 1/3. And for this, we have taken different levers. Next slide. Yes. And how did we achieve it? These are the 5 levers which we have worked in. So clinker substitution, AFR, energy productivity, clean and green energy, and innovative building materials. And I would not go into the details. I have already, I guess, gone beyond the allotted time. So what we say, that all the industrial companies, especially which are representing steel or cement sector, we have to reduce our emissions so that we can reduce the overall emissions of the building. Thank you so much.
Thank you so much. Thank you for joining while you. Yes, thank you. Then I request Professor Srinivas from Geetham University, Vizag, to give his presentation, please. Thank you.
Yes, sir. Good evening to all of you. Today, I am presenting my talk on environmental remediation for land restoration. As you know that environmental. Next slide. So environmental remediation is upcoming an area because most of the land is now getting contaminated by various sources. So there are the 2 terms I am presenting here. One is remediation and the second one is the restoration. So environmental remediation is the cleanup of hazardous substances, dealing with the removal of various type of pollutants or contaminants from environmental media, that is maybe some soil or water or from the sediment. Whereas the second term is a restoration of land. It is a corrective steps that involves the eliminating the modifying causes of ecological degradation. So both are interrelated each other. But after in the environmental remediation is required restoration, because to build up a ecosystem, sustainable ecosystem, so we have to apply certain ecological principles to bring them into the what called as a natural process. Next. So environmental remediation is done by various processes. There is a physical, chemical, and biological process are there. So among the thing, I am stressing mainly on the biological one, that is consist of both microbes and plants. So next slide. Because in the both the physical and chemical remediation, there is a what call it, when the area is limited, the physical and chemical process are economical. But when the area of the land is need to be remediated in a larger area, then the biological methods are more convenient. So that is the, for example, if we take an area of mining areas, abandoned mines, or the municipal dump yards, industrial areas, sludge disposal sites, for example, these are the areas where we can come across in the contamination. So the contaminated lands is generally responsible for what called as responsible for the spreading of various kinds of pollutants, particularly the heavy metals. Heavy metals are which are very commonly present. So these heavy metals pose what called health risk, particularly because when a soil get contaminated with heavy metals, then it easily enters into the human food chain through the plants and in the form of a fodder to the what called cattle, through milk enters into the human food chain. So here I'm showing a concept which is known everyone, but what we did is here is applied in a different way. So that is phytoremediation process. Because as I already mentioned that when a land is contaminated, the physical and chemical methods have its own limitations because of applicability and cost involvement. So in the biological method, the phytoremediation, which is a very convenient, because economically viable and easily, and it is and a sustainable way we can remediate the contaminants. For example, you see that the possible way of land getting contaminated, either industries emissions or industrial effluents, industrial solid waste. Similarly, the wastewater treatment plants and soil, dump yard soils, all these are the various sources for causing contamination to the ground. So now there is a proposal for that says these contaminants, how to treat the contaminants. This is a challenging task. So the treatment of a contaminants in a sustainable way or a green way is only possible through either phytotechnology. But phytotechnologies also have a certain limitations. What is that limitation? The availability of metals. That's why what we did in the Geetham, we have applied a electroremediation technique, which is also low-cost technique, by giving a small amount of current volts into the soil media that gives what you call that makes metals into the available form. Then the thing is, why phytoremediation is only chosen? Why not the other method? You see that the advantage of phytoremediation, the metals can be excavated into the plant parts, and that can be what called as arrested in a biomass. The biomass, when it is converted into ash, the quantity is very less. So so that we are containing the contaminant into a lesser quantity, so that is the disposal in either sanitary landfill or maybe some other kind of an extraction is become a beneficial. The second one is next slide. So these are the various kinds of phytoremediations. But here I am showing, next slide. I am showing particularly the sewage sludge. Why sewage sludge? Because the wastewater treatment we have developed a very good technology. Even the grey water we are treating up to a drinkable level. But we are not having a good efficient technology for disposal of a sewage sludge. because the sludge which comes from the wastewater, which contains very high amount of contaminants of both organic and inorganic, which contains particularly very toxic metals. Now, the annual production of sewage sludge in all over the world is 53 million tons per annum. Next.
Professor, you have to conclude in a minute, please.
Next.
Sorry.
The next. So this is the quantity of sewage sludge which is generating. Next. Go for next slide. So the sewage sludge disposal methods is mainly the landfilling is only the method at present is applying. When compared with the incineration or where maybe other application to the agriculture, because that needs certain statutory requirement for application. Next slide. So that is the reason the phytoremediation is only the best option for economically viable to treat the waste. Next. Just I wanted to show you some of the plants which can able to accumulate. Next, you go for next one. Go for next. Yeah. So this is the hyperaccumulator. Just I wanted to show the significance of the work. See, that's what next before slide. 1 minute only. Yeah. So the mainly what is they showing is, this is the see that's one plant like Talaspi. It can able to accumulate cadmium 1800 ppm. It means one ppm of cadmium itself it a cumulative poison. But how the plant can able to accumulate such a higher quantity without affecting its metabolic activities? That's why the hyperaccumulators which are naturally available, we can use these what called hyperaccumulators for treatment of waste which is in an economical way. So this is the one of the land restoration option which is very economical to India. Thank you. Thank you for giving me an opportunity.
Ms. Joshi from Godrej and Boyce, and she will talk about.
Thank you, Dr. Ghosh, for inviting me for this session. I'll be speaking on the recycling and production of low carbon build materials using construction and demolition waste. Largely, my presentation will have three aspects: setting the context, recycling concrete debris, and our experience on that, and challenges that we have and opportunities in this particular area. Now, just to set a context, globally, solid waste, which is a growing concern across the globe, it is estimated that nearly 3.4 billion tons of solid waste will be generated per annum by 2050. And with that, we can understand the kind of enormity of problem that we are looking at. And to add to that, the construction and demolition waste is a significant part of the total solid waste component. And here we are talking about 20 to 25% of the total solid waste is formed by construction and demolition waste. And the construction industry is also the #1 consumer of global raw materials. So by an estimate of World Economic Council and BCG, more than 38 billion metric tons of non-metallic minerals are extracted from the earth every year, and construction industry being one of the largest consumer of these raw materials. So, and then we today, when we're talking about decarbonization, essentially we look at embodied carbon of materials. So, when you see embodied carbon in construction materials, we look at the building operations as one of the focus areas, but the embodied carbon of material is a big black hole, and we are trying to understand it. And here, when you see, it still forms 11% of the footprint, of which 23% basically is coming from concrete, steel, and aluminum. So we're looking at concrete as a very large component of embodied carbon here. So, and what is the problem today? And these are the scenes we see in every city. So indiscriminate dumping of construction and demolition waste is a major concern for not only the authorities, but also the residents of the cities. Causes enormous problems to the residents in commute, in many other aspects. So what it happens, how does it impact? The adverse impacts are unauthorized dumping illegally leads to congestion of roads and breeding spots for diseases, clogging of landfills, because a large part of solid waste is formed by construction and demolition waste. There is dust pollution by lifting and moving the material from one place to other. It deteriorates the air quality of the entire city. leads to urban flooding, because these C&D waste actually end up into water drains and clogging them, which leads to flooding of the city in rains. And because of that, there are also problems of contamination like leaching, which basically creates groundwater pollution because of this waste going on into our water bodies. So and then let us look at the Indian scenario. So concrete is a major component in the overall construction and demolition waste volume. So we are going down into brief, breaking the concrete as a component of C&D waste. Almost 25 to 35% of C&D waste is composed of concrete. And also, if we look at a context in India, officially, India generates around 150 million tons of construction and demolition waste annually. Unofficially, of course, the figure could be around 3 times higher than this. So this is the kind of problem that we are trying to address by this particular initiative. Also, the scenario holds that C&D waste recycling plants in India today essentially is only able to manage around 1.3% of the construction and demolition waste today generated, as per one of the analysis by Center of Science and Environment. And there are sporadic places where construction and demolition waste facilities have come up decentralized in different areas, but the solution today available is very, very low as compared to the requirements. So Godrej & Boyce has been recycling the concrete debris, and this plant which we have set up in the suburb of Mumbai in Vikhroli since in 2017-18. I am sharing the experience of this that we have done. So we have basically to demonstrate the circular economy principle, to see that the material, once it is extracted, also can be, at the end of its life, can be used back into the same kind of product. So what we do here is the demolished waste from the construction sites, the concrete rubble comes to a manufacturing facility in Vikhroli, where it is pulverized and then converted into recycled aggregates. These recycled aggregates go back into concrete blocks and pavers and building blocks, which are again used back into our building projects. So here we are actually from a building, the material goes back to a building, demonstrating a true principle of circularity. So far in this project, in this plant, we have recycled over 25,000 metric tons of concrete debris over the last 6 years. And we've demonstrated successfully with all the tests that these material building blocks are as good as any virgin concrete material blocks. And this is a photograph of the facility. This is the first ready-mix recycled concrete material plant in India, which is powered 100% by green energy. And it has capacity to process around 300 tons per day of concrete debris, manufacturing around 36,000 blocks and 54,000 pavers per day. And that's the capacity it has to handle concrete waste from the construction and demolition waste. This is a certified Green Co certified manufacturing facility. At the same time, these products are green certified through Indian Green Products and Services Council for Green Pro certification. And since then, since 2018, these products are green certified. And it also has received the ISI certification for concrete products, which are applicable to these kind of building blocks. And here are some of the pictures of the concrete blocks and pavers, which are manufactured using recycled concrete aggregates. We have also used the recycled concrete material in the box culvert segment of Municipal Corporation of Greater Mumbai's Mumbai Coastal Road project, which is one of the most prestigious projects in Mumbai, along with the PMC and general consultant, where we could convince the architects and the project consultants that these were as good material as a virgin material to be used, substantiating it with all the technical tests and reports. And these are the kind of box culverts for stormwater drainage which were used in Mumbai Coastal Road project, which are manufactured using recycled concrete material. And there are many other applications. You can use this for street furnitures, in the landscapes. What we have also tried is using this material in 3D concrete printing. And what you see here is a pilot bus shelter, which is a 3D concrete printed structure, which is using recycled concrete aggregates and material as a component of the 3D printing material. And these are the views of this. Is a concrete printed bus shelter, which is also demonstrating two technologies. One is the 3D concrete printing, and other is the use of recycled concrete aggregate. Now, also, we have been collaborating with SINTEF, a Norwegian project on C&D waste, where experts from SINTEF has been analyzing the carbon capture capacity of recycled concrete blocks. And these blocks have been tested in the Norwegian test laboratories by Dr. Kristin here, that you can see in the picture. These concrete blocks were taken from our facility to look at the carbon absorption in these blocks. And the tests were carried out for the CO2 binding on the Godrej blocks. And what we have actually basically been able to say here is, the blocks were crushed and then exposed to varying pressures of CO2 to look at the absorption. And here are the test results. If you see, these blocks actually take up a lot of carbon dioxide in various relative humidities. At the 70%, which is a kind of a Mumbai scenario, you see the amount of the green line is the recycled concrete aggregate blocks that takes up CO2 binding, demonstrating that there is a carbon sequestration in the blocks over the period of time as they get used in the buildings. And what we are now also embarked is looking at how do we do an environment product declaration for these blocks. We are again work with partners, the SINTEF partners, to develop the EPD analysis, the life cycle assessment, and declaring for the product environment product declaration. We have also made this presentation to a national workshop held by the Ministry of Environment and Forest in Vigyan Bhavan, to again demonstrate how these materials of alternate materials using recycled concrete debris or recycled concrete aggregates are as good as virgin aggregates and virgin materials, and with a very large amount of environmental benefits that we can have, and it is as good as any virgin material products. So, but of course, every initiative comes with its challenges and opportunities, and there are many.
You need to conclude quickly.
Yeah. If we look at the challenges, there needs to be a lot of work done on the guidelines, the mandate for use of recycled products in government and private sectors, incentivize use of or some tax rebates for recycled products, amendment in the applicable IS codes for increasing adoption of recycled products. Need to stop control indiscriminate dumping of C&D waste. Proper segregation, collection, and disposal of C&D waste is very important. Effective laws need to be there. And all of these will lead to higher absorption of recycled concrete material as a component. And we have provided guidance and support to multiple stakeholders across India for establishing C&D waste recycling plants. And here are some of the examples. Of course, this initiative has been rewarded with many awards by national and international level. And with that, I end my very short presentation on this topic. Thank you so much for giving me this opportunity, and I hope I was able to complete.
Yes, we gave you a little bit more time. Okay, we go to Professor Sadhan, if she has joined already to make a presentation on the environment. Yes, I can see you now. Yes, Professor.
Morning.
Yeah.
Sorry,
yeah.
I thought it was supposed to be 3 o'clock.
No
I'm
problem,
sorry.
Professor. Please go ahead and please stick to the key message. We are running little. We are little
I'm
late.
sorry. Good afternoon, everyone.
So please, thank you so much. Over to you.
Yeah, my name is Dr. Olatokunbo Featon from Covenant University, Department of Civil Engineering, and I'm going to present on Our Land, Our Future, a call to sustainable stewardship.
Maybe you can make it to presentation.
Introduction.
Okay.
What then is land? Examining the status quo of our land, how it has gone to degenerated this far, and the emergency, how did we get there, how do we change, and the journey so far in Nigeria's stewardship, and the challenges and the future direction. What is land? Land is the home for every living organism, and it is fundamentally necessary for every one of us to exist. Every one of us, we exist, and what are the things that we do with our land? We build, we have microstructures, we eat. Most of the food that we eat come from the land. a lot of things are drawn and made from land. The existence and survival and the future of man is in the land. What then is land? The land provides physical space and natural resources necessary for various types of production. We have plants here, we have timber, we have mining. And then, where are we now? The situation of land. There's limited data on the particular expanse of land and the conservation of land that we have now. And the world readers met in the United States during the Brazil climate in Brazil during the formation of the SDG goals. And then they were able to come to a conclusion that SDG 15 had to do with life on land. And then examining the status quo now, according to the United Nations, the statistics that about 25% of the total land area of the earth has actually degenerated, leading to current global food insecurity, climate change, and loss of biodiversity. Also, the agricultural sector has not been left out. We have lost a lot due to unsustainable agricultural practices. Animals and species also too had their own and actually really suffered. Then how did we get there? Indiscriminable agricultural, poor farming practices, improper livestock keeping, illegal mining practices, and then dumping of non-biodegradable trashes such as plastic, cans, trash, nylon, and all sorts into our river and our sea. And then exposure of naked soil using, after harvesting, mining with heavy equipment, increase in field size due to economic or scale, reducing shelter for wildlife, and the indiscriminate use of land use charge, and also indiscriminate use of mineral and ore. And how did we get there? We find out that here in this picture shows the area of expanse of agric. We have left it undone. Here we have the plastic, here we have mining, and here we have farming. Now, how can we actually change the status quo? And this calls for a change to action. One, we need to adopt legal mechanisms to ensure a fair sharing of benefits from resources and implementing sustainable environmental management strategy. Two, by embracing sustainable practices, having innovative technologies in the area of farming, in the area of building, collaborative governance, both individually and as a nation, to help us to reclaim our ecosystem back and to have a balanced ecosystem. Now, what are the possible ways? We have to embrace renewable energy resources, that we ensure that there is a reduction in carbon footprint, implementing regenerative agriculture practices and restore ecosystem, fostering eco-friendly infrastructure and sustainable urban planning, supporting indigenous communities and their ancestral knowledge, and then education, that is empowering the future. The journey so far on sustainable stewardship in Nigeria have been able to formulate policies, environmental policies and regulations, renewable energy and clean technology, agricultural sustainability, conservation efforts, and waste management and pollution control, and also to help mitigate the change. And also on the area of education, there has been a global awareness around Nigeria. What are the challenges and the future directions? Sustainability stewardship in Nigeria encompasses various initiatives and policies that have helped us to balance economic development and environmental protection and social equity. The National Environmental Standard and Regulation Enforcement came out with a policy that is responsible for enforcing environmental laws and regulations to ensure sustainable development in Nigeria. Also, the Nigerian Environmental Action, the plan outlines the country's strategy for addressing environmental issues that includes deforestation, desertification, and pollution. You cannot just cut down trees anyhow. Then two, renewable energy.
Doctor, please conclude in a minute.
Okay, also in the area of renewable energy, that is the production of solar projects, also have agricultural sustainability. And then fourth, we have the conservation efforts, a biodiversity production that protects Nigeria's rich diversity, including the establishment of natural parks and wildlife reserves. And then here we have the waste management and pollution control, a waste to wealth initiative program that promotes recycling and waste management to reduce environmental pollution and to create economic opportunities. And then also have education awareness, the environmental education, that is to initiate this environment into school curricula and public awareness campaign to promote sustainable practices and capacity building. And in conclusion, what are the challenges? One of the major challenges that we have is the strengthening of environmental governance, increase in
Thank you, Doctor, for finishing it on time. Thank you so much. So then we have the last presentation from Mr. Vidyut Bose from the Vishnupur High School in West Bengal, India. We'll talk about the outreach activities in his school. Over to you, Mr. Bose.
On behalf of my school, Vishnupur High School, I want to thank Professor Sadhan Ghosh and ISWMAW for inviting us. We all know that environment imbalance is the current burning issue for the whole world as well as India. We all try to save this world from this imbalancing problem or the wastage. Here, ISWMAW like organizations has the important role. With the collaboration of ISWMAW, our school, we try to grow interest and awareness among the students through Catch Them Young programs. We try to grow interest and awareness among students. We ensure it from the root. Now, I reduce my introduction part because I have the time limitation. This is my topic. We know the urban area has the basic dependence on land, soil, water, air, etc. But these sectors are in deep danger. I am not going to find its reason. ISWMAW and we are interested in finding its solution and working on the solutions. This is the problems and the solutions. Now, the role of the mission Catch Them Young, Geo Waste and Circular Economy in campus. Here, we know the charity begins at home. But in this case, ecosystem restoration management begins at school. We know students are the future of our nations, so they have to know how they save our environment. We can make them aware in this regard that they surely understand what they should do. We introduced bin culture concept in campus such that students dumped their waste in correct bin. There are mainly 3 types of bins: green bins, white bins, and red bins. This is my school, and this is the structure of a bin culture. Here we put the guideline also. Green bin for biodegradable wet waste like rejected part of vegetables, food waste, leaf, flower, etc. White or blue bin for biodegradable dry waste like clothes, machinery waste, dust, metallic wastes, paper, etc. Red bin for mainly plastic waste. From green bin waste, we make organic fertilizer. We use it in our kitchen garden, in our own roof garden, etc. We can sell a red bin waste to the correct buyer. You know, nowadays the many startup industries works with it, and they reuse it, make cement, road material, etc. As earlier, Dr. Shiv Kumar or Mrs. Monica says about this. Now, in our school, we have the classroom waste management and midday meal waste management system through this bin culture. We put these 3 bins in our own school classrooms and midday meal sections with proper guidelines, and students use it. At first, we make aware all the students how to use it and then put the bins in the right place. The same procedure maintained in midday meal sections. This is our kitchen garden. You can see this. Green environment in our school. All these are possible through our organic fertilizer. We aware the students about the role of child cabinet. We aware them about class monitors and role of teachers, HM, SMC, all are there. We conduct a program with Catch Them Young, Zero Waste and Waste Circular Economy in our campus banner with ISWMAW. And we make a rally with all the delegates. You can see Prof.Sadhan here and all the school students and teachers for the public awareness. We take oath. All the teachers and students are taking oaths here. This is some of the pictures here. That's the end of my presentations. You can see how under the banner of Catch Them Young, Zero Waste and Circular Economy, our schools works always with the collaboration of ISW and MAW. Thank you.
Thank you so much, Mr. Bose, and wish you all the best for your future work. It's very important to this catch them young concept to imbibe this environmental, principles and practices while they're still young.
You know that out of 716 million tons, we are only recycling 1.6% or something like that. So this is really a niche area for business as well as for taking a lot of actions. In ICON SWM, International Conference on Sustainable Waste Management, to be held in Vizag from 28 November to 1st December, we will be establishing one ICON Excellence Award for construction and demolition waste management and recycling. And our Christian from SINTEF, Tejashree and Shiv Kumar, these 3 persons along with a few friends will be in the award design committee. The the questionnaire design and all these things. So we will write to you.
Sure, sure.
My point,
My
yeah,
pleasure.
thank
Yeah.
you, thank you. But my point here is, you have shown the boxes, okay, which replace some other material, like traditional construction material to recycled construction material.
Correct.
So if you can give some idea about the cost part, like the difference or the percentage of cost part, so that will be beneficial for all of us.
Yeah.
Please.
Yeah. So if you actually consider
And Shivakumar also can add some value to it if it is needed. Yeah.
see, as far as the cost is concerned, for particularly being able to make products from construction debris, the real cost comes in the quality of material that comes in as a raw material. Where the cost increases. So therefore, I think it is very important that the demolition happens in the right manner, where the every component of the waste which is generated after demolition gets segregated right at the source of generation, point of generation, as we say. If there we are able to segregate this in proper way, and you can segregate out the concrete debris from the overall construction and demolition waste, the channelizing of that concrete debris as a raw material for the next production of products using recycled concrete aggregate becomes easier. The real cost comes now, which is an incremental cost as against a normal concrete block, is this cost of material handling, getting the right kind of material, getting it segregated, and making it proper for further process for recycling. So what we also do is work with projects which are getting developed right at the demolition stage, along with the demolition contractors, in terms of creating SOPs, what could be the right way of demolition, so that the material at that point of time itself, the quality is maintained, and then the work for further segregation and cleaning up the material is reduced. But if you ask me, as far as the cost component is concerned, currently it turns out to be a little more costlier than a normal, concrete block, which is a set mechanism. And this mechanism is not yet set. And that's where the ecosystem needs to evolve in terms of creating the right material. But however, when you're actually competing in the market, you need to fight on the same cost as any other product available. But the USP remains that it's green quotient in terms of the embodied carbon, lesser embodied carbon and energy it has used. The green, as a certified green product, that we sell it for green building construction, which then helps the green building construction in terms of improving their ratings. These are the USPs then you have as levers to use for increasing the business. As far as price is concerned, we need to compete on the price at market price levels today. And that's where, some incentivization in terms of some differential taxation could be as a leverage point, when that's what we have been putting forward to also the authorities in terms of facilitating the uptake of green materials or green products.
To what Tejasvi was saying, for example, we are constructing a new precast factory in Navi Mumbai, where we find that the recycled sand is about twice the cost of natural sand. So we are actually spending money for a demonstration project, again in collaboration with Dr. Christian. So the cost component has to level off, or it has to be slightly lower than the natural material, then only the uptake will be more. So as contractors, we always are concerned about the cost part. Actually, the lowest bidder gets the project, and then everything cost is a driver. Yeah, that's all my view.
Of course, another point is the life cycle. Life cycle comparison.
Yeah.
With the fresh material. And
see, that's where, we actually, when you can qualify a product as green, is when you do the life cycle analysis and compare it with the life cycle of the base case. And this is the new design case. And that's how we come out with the result of differential between the life cycle impacts of both different types of products, and show, the green quotient of the product.
Yeah. And I think with the price on carbon, whenever it comes, then the first movers like L&T and Godrej will have an advantage. because then maybe it will become economically more incentivized to take up this environmentally benign products compared to the traditional ones. So
Yeah,
there
I
lies
think
the
carbon
viability gap.
pricing is something probably, I don't know in India how when it will come, because it's a very cost sensitive market as well, we know, and anyways so much of taxation. But I think what it requires is a policy push in terms of promoting this material, and that will increase the acceptability. Somewhere regulatory push also helps in this. Like we are looking at, the whole ecosystem development of recycling of construction demolition waste. If there is a regulatory intervention, just like the e-waste or plastic waste, it will give it a push and the momentum to the entire ecosystem to develop further. And once there are more players and more robust ecosystem development, the prices come at parity, and
So you mean some minimum percentage usage of recycled products in a project?
Absolutely. One is, yes, the acceptability is basically the IS codes need to look at more higher usage of recycle, which has been proven technically, but still because the codal provisions are not there, uptake also is limited. That's another aspect. And somewhere to promote these kind of products, because we are looking at resource efficiency as a very big focus also in the national resource efficiency policy. I think somewhere incentivizing such kind of products in terms of taxation differentials will help a long way in terms of pushing this in the market.
That's a resource efficiency one, the national resource efficiency. Another is so much of awareness. Mass awareness generation is a need for at least construction and demolition waste use. Though there is a GVC requirement for certification, but that's a very small number. Right.
Yeah.
I'll take advantage of the presence of Dr. Kare Karstensen here. So, Kare, you are here. I can see the name.
I am still here. Yes.
Please. So, you know that RDF and Wests, these are all used nowadays in many of the cement plants in India, of course, in other countries. So many people in our country don't know that the building where they are residing, it may be made of the waste which they have generated sometime. So I like to have some idea from you that the material, the cement generated from using waste and the cement generated from the traditional material.
I think we have had some very good presentations, which Skore Helge talked about 5 billion tons of non-recyclable plastic waste, which is lying in world's environment, and no one is talking about it, and how co-processing and other technologies, co-processing can be a viable option. We heard from Miss Monica and Miss Joshi, who talked about CO2 impact on the built environment and good work that they're doing to reduce their carbon footprint and new product development. We heard from Professor Srinivas, who talked about phytoremediation and how it can actually solve the problem of more than 5 million tons of sewage sludge that we have today, which is not properly managed. And then we heard from Mr. Bose, who is doing a good job. And as I understand, ISWMAW have this program in more than 50 schools and approaching almost 100,000 students, trying to build kind of an awareness about sustainable waste management, environment practices, everything. I will actually prepare kind of a chair summary, which I'll share it with Professor Ghosh, and then it can be redistributed to the participants. And I also thank Valerie for trying to also coordinate this session along with me, and congratulations to all the good work everyone is doing, and see you next time, hopefully in Vizag. Thank you.
Thank you.
Thank you. So it's the time to conclude the session.